In this particular session, we are going to discuss about stack data structure. So in the last week, we were discussing about linked list, right? So this session will discuss about stack data structure. And stack is also one of the linear data structure which we are going to see now. Okay, stack. So what is the concept of stack? Any idea about the concept of stack? Stack is one of the linear data structure where we used to keep elements one by one. We used to keep the elements one by one. For example, let us take a pile of plates where the first plate has been kept and then second plate, then third plate and then fourth plate. This is how I'll be inserting the elements inside my stack. For example, I'll take a stack data structure where first element will be inserted, then second element, then third element, then fourth element, then fifth element. This is how the elements will be inserted inside my stack. In case if I want to remove my third element, can I take my element directly from the stack? Obviously no. This cannot be done. So if I want to remove the third stack, third element, I have to remove sixth element, fifth element, fourth element, and then only I can remove the third element. This is how we have to remove the element from the stack. Here we used to say stack follows the concept of last in, first out. Okay, last in, first out. This is how we used to go for the stack data structure. Okay. The real-time applications of stack, I can say, is nothing but the messages which we are receiving in our WhatsApp. Okay. For example, the first message I'm getting. For example, I'm getting a message from my first friend. Then I'm getting a message from my second friend. So the message which I've got from the second friend will be on the top of the message in the chat box. Okay. So this is how the messages will be kept on. Messages will be displayed in the order. Okay. Now in depth we'll go and see what is the concept of stack. So stack follows order called last in, first out. We'll be calling it as LIFO. Okay. And the last element to be inserted inside the stack is the first element to be deleted from it. Okay, the element which I've inserted at the last will be removed first. That is why we'll be calling the data structure concept as last in, first out. We'll be calling it as last in, first out. Okay, next, both insertion and removal are allowed at only one end of the stack because both ends will not be kept open here. When you go for stack data structure, both ends will not be kept open. Only one end will be open. So the insertion and deletion both should happen at the same end only. That we have to keep in our mind about the stack data structure. For example, I'll take this is one stack where the insertion as well as deletion both should happen at the same end. Okay, now let's try to see what are all the functions we can do with the help of stack data structure. The first function we'll be calling it as push function. So push is nothing but element which I'm going to insert into my stack. The concept, if I want to insert an element inside a stack data structure, I'll be calling it as push. Okay, next function, pop function. If I want to remove an element from the stack, I'll be calling it as pop. If I want to remove an element from the stack, I'll be calling it as pop. And next one, peek function. So most of them might have not heard about this concept called peek function. So peek function is nothing but which helps us to know what is the topmost element which is present on the stack. I'll repeat, peek function is the one which helps us to know what is the topmost element of the stack which is present. And the next one is nothing but overflow state. Excuse me. Overflow state. So here we will be calling it as two states. One is overflow state and the next one is nothing but underflow state. What is meant by overflow? So by the name itself we can get to know that overflow means when the stack is full. For example, I have a stack. Okay, the size of the stack is only 5 elements. The size of the stack is just 5 elements. If I am trying to insert my 6th element, is it possible for me to insert my 6th element inside my stack? No, because the size of the stack is 5 and I try to insert one more element, that is not possible. So that is called as overflow state. And the next one is nothing but underflow state. So what is mean by underflow state? Underflow state is nothing but when the stack is empty, but still if you are trying to delete an element from the stack, that is called as underflow state. Guys, were you able to understand these functions? First one we are talking about push function. Next we are talking about pop. Next peek function. next two states we were discussing. One is nothing but overflow state and the next one is nothing but underflow state. So is it clear? And there are many more applications of stack. So when I say many applications of stack, we'll be calling this expression evolution, and next we'll be calling it as expression evolution is one of the best applications of stack, I can say. One more thing we can talk about is recursion. So recursion is one of the best one more applications of stack, because how recursion works. So recursion is being working with stack data structure, because first recursive call, second recursive call, third recursive call, fourth recursive call, fifth recursive call, and the top recursive call will be executed first, then the next recursive call, then the next recursive call, then the next recursive call. This is how the recursion works. Okay, we can say recursion is also one of the examples of stack. Okay, underflow state. Underflow state is nothing but when the stack is empty and if you are trying to delete an element from the stack. Okay, let us take, this is my stack data structure. Okay, here this is an empty stack. This is my empty stack. When the stack is empty and I am trying to delete an element from the stack, can I remove any element from the stack? Obviously I cannot remove any element from the stack. So this is called as underflow state. So remember the two states, overflow state and the underflow state. These are the two states which we have to keep in our mind from stack data structure. Fine. Next, I'll give you the examples of stack. So let's see in a visualized manner. I mean, with an animator format. So when the stack is empty, so we can get to know that stack is empty when the top value is equal to -1. We can say when the stack is empty. So with the hint we can say if the stack is empty, the value of top will be -1. So when the value of top is -1, we can say that the stack is empty. Okay, initially top of the stack will be -1 because initially the stack will be empty only, right? Initially we will not have any element inside the stack. So initially we will be having an empty stack. So when the stack is empty, the value of the top will be equal to -1. Okay, with the help of the top value, we can get to know whether my stack is full or empty or it contains any elements inside the stack. Here, let us consider the size of the stack. Okay, let us consider the size of the stack be 3. Okay, here let us consider the size of the stack be 3 because we have to know whether the stack is full or empty, right? So for that, we can get to know with the help of the top value. Okay, so when the top is equal to -1, which means the stack is empty. Now let's try to insert an element called 1 inside the stack. Okay, I'm going to insert an element called 1 inside my stack, which is nothing but push. So insertion is called as push, deletion is called as pop. Okay, so I have inserted an element called 1. So when I have inserted an element called 1, the value of top will be incremented by 1. The value of top will be incremented by 1, which means that top value will be incremented by -1 to 0. Top value will be incremented by -1 to 0. When the value of top is equal to 0, which means that it has element. I have my first element inside my stack. Now let's try to insert one more element inside the stack. I am going to insert an element called 2 inside the stack. So if I insert one more element inside the stack, the value of top value will be incremented by 1, which becomes 1. Now I am going to insert one more element inside my stack. Now I am going to insert one more element inside my stack. So which is called 3. So when I am going to insert one more element, the value of top will be incremented by 1. The value of top will be incremented by 1, which becomes 2. Top equal to 2. Now for example, I am going to insert one more element inside my stack. Okay. Now I am going to insert one more element inside my stack. Okay. I am going to insert the element called 4. So remember one thing, inside the push function, we have to remember one thing when we are inserting an element. So whenever you are inserting an element, you have to check one condition. What is the condition we have to check in the sense? If the value of top is equal to size -1. If the value, so what is top value? 2. What is size value? 3. 2 equal to 3 minus 1, 2. When 2 is equal to 2, now I can say my stack is full. Now I can say my stack is full. I cannot insert the fourth element inside my stack. I cannot insert my fourth element inside the stack because the size of the stack is 3. I have inserted 3 elements. Now I cannot insert any more element inside the stack. Okay, so whenever you are writing a function for insertion of element inside the stack, you have to remember this condition. If top is equal to size minus 1, some people used to say if top plus 1 equal to size, that depends upon your convenience. Okay, you can give if top plus 1 equal to size. Even this condition is correct. Top value is 2, 2 plus 1 3, size value is also 3, 3 equal to 3, yes, condition is true. So if this is the case, I cannot insert my element inside the stack. Here you can display a message saying that print, I can say stack is full. Stack is full. Else, here you can write the logic of insertion of element. Insert element. Here you can write the logic to insert the element inside the stack. Okay, this is the concept of push inside the stack. Hope this is clear for you. Is it clear, guys? Do you have any doubts till now? So when you are inserting an element, you have to check one condition. If top is equal to size minus 1, stack is full. If stack is full, I cannot insert an element, so I can display a message saying that stack is full. Else, I can go inside, I can insert my element. Hope this is clear for you. Now let's move on to the next function called pop. So which element can I pop first? Always the topmost element can be popped from the stack. So what is the topmost element? The topmost element is 3. So I can remove the element 3 from the stack. So I can remove the element 3 from the stack. So when I remove the topmost element, the value of top will be decremented by 1. When I remove the topmost element, the value of top will be decremented by 1. Before removing the value 3, the value of top is 2. Now I am removing the element 3. If I remove the element 3, the value of top will be decremented by 1, which becomes 1. Now when I try to delete one more element from the stack, which is 2, I am trying to delete the element called 2. When I delete the element called 2, the top value will be again decremented by 1. Now let me try to delete the element which is present inside the stack, which is 1. So if I delete this, the top value becomes minus 1. So as I said earlier, when the value of top is equal to minus 1, we can say that the stack is empty. When the value of top is equal to minus 1, we can say that the stack is empty. So whenever you are writing a function for pop for stack data structure, you have to check one condition. What condition should I check? Which is nothing but if top is equal to minus 1. If the value of top is equal to minus 1, I can say that the stack is empty. So I can print a message, print stack is empty. You can print a message saying that stack is empty. Else you can delete an element. This is the concept of stack data structure. So here we have to remember one thing. I have inserted the element in the order of 1, 2 and 3, but I have deleted the element in the order of 3, 2, 1, 1. So obviously the order which you have inserted inside the stack will be reversed when you are popping the element from the stack. Okay, remember, whenever you are inserting an element in certain order, whenever you are popping, obviously it will be in the reverse order, because stack follows the data structure, stack follows the order called last in first out. Because of this, we will be getting the elements only in the reverse order. Okay, so whenever you are inserting an element, you have to check one condition. Whenever you are deleting an element, you have to check one condition. So the condition to check whenever you are inserting an element is if top equal to size minus 1. If that is true, stack is full. When the stack is full, we'll be calling it as overflow state. If the stack is not full, I can insert the element inside the stack. Similarly, whenever you are going for deletion of element inside the stack, so if you have to check one condition, if top is equal to minus 1, print stack is empty. When the because I cannot delete element when the stack is empty. That is called as underflow state. If the condition is not true, I will go for else case, I can delete the element. Okay, Chanakya, I will write the program for this stack, don't worry. I am just explaining the concept of stack now. Okay, fine. So this is the concept of stack data structure. So whenever you are learning the concept of stack, you have to remember these two things. Okay, but the concept, that is the thing, but the stack data structure can be implemented with array or linked list. With the help of anything, you can implement the stack data structure. It doesn't mean that I can implement stack data structure only in array or only in linked list. We know the difference between array and linked list. Based on the benefit of the particular concept, we can implement. Okay, so for that you have to be familiarized with the difference between arrays as well as the linked list, because array and linked list both are equal. We cannot say one is better than the other. Based on the situations, we can say this is better than this. Okay, if I want to have elements in the continuous order, I can say array is best. If I don't want to have the elements in the continuous order, I can say linked list is best. Okay, so based on the needs, we can implement the data structure concept called stack with the help of using array or linked list. Okay, now let's go for one more applications of stack, which is nothing but expression evolution. So far, I hope everyone are clear with the data structure concept called stack. I'll give a minute of time. If you have any doubt in stack data structure, you can ask us, guys. By the end of the session, I'll take a program and I'll execute and show you how to write a program for stack data structure. Okay, I guess you don't have any doubts in this. So far it is clear. Now let's move on to the concept called expression evaluation. Expression evaluation is one of the applications of stack. When you are preparing for placement point of view, this is one most important concept you have to learn from stack, expression evaluation. So when I go for expression evaluation, we have three notations. One is infix notation, next one is prefix notation, and the next one is postfix notation. So what do we call infix notation? Which is nothing but to write a comma b, we'll be writing is a plus b. So here a and b are called as operands. Plus is called as operator. Okay, here a and b are called as operands and this plus is called as operator. Next, when we go for prefix notation, so how can I denote the prefix notation? To write a comma b, we'll be writing it as plus ab, where plus is an operator, a comma b is an operand. So in infix notation, operator will be placed between the operands. In infix notation, operator will be placed between the operands. When I go for prefix notation, operator will be placed in the beginning, then the two operands will be placed. Next, when I go for postfix notation, so how can I denote postfix? In postfix notation, first I have to have the operands, then I need to have my operator. First I need to have my operands, then I need to have my operator. This is how I can denote the expressions. So by the name you can get to know the notation, infix notation, prefix notation, postfix notation. So when I say in, so in which is between, so operator has to be placed between the operands. Prefix, so we used to say pre, right? Pre means before. So operator has to be placed in the beginning, then I need to have my operands. Next to postfix notation. So post, when I say post, first operand should be there, operator will be placed at the last. So this term denotes the operator. Where should I keep my operator? In. So operator has to be placed between the operands. Pre. So operator has to be placed before the operands. Post. Operator has to be placed after the operands. Okay. Now let's go for one more example. I told this is called infix, prefix and postfix. Now let me take one example of converting from infix to postfix notation. Okay. We know how infix notation works. How infix notation works? The operator will be placed between the operands. Okay. Now we are going to convert the given infix notation to the postfix notation. So when I say postfix notation, how should I have? I need to have the operator at the end. First I need to have my operands, then only I need to have my operator. This is how I will be writing the notation of infix to postfix. Now we should know how to convert infix to postfix notation. That is one more thing, right? So this can be written, the program can be written with the help of the stack data structure. Now I am not going to write the program for this. I'll explain the logic first. Because if we know the logic of this, we can write it very easily. Okay, first they have given the infix notation. So I'm going to take a stack. This is the stack. Because in stack we are going to insert the element, right? Okay. Now first thing, the first element is nothing but open bracket. So whenever you have brackets, what you have to do in the sense, you have to insert into the stack. Remember, I'll tell step by step. Just understand the concept of converting infix to postfix notation. So first thing is open bracket. So whenever you are getting open bracket, insert into the stack. Okay, I have inserted. Go for the next element. Again I have got open bracket. So if I have got open bracket, what should I do? I have to insert into my stack. So I'll have inserted inside my stack. Then I'll go for next element, which is nothing but open bracket. So I have told you, whenever we are getting open bracket, I have to insert that bracket into the stack. Okay, next I'll go for the next element. My next element is A. A is an operand. Okay, so whenever I'm getting an operand, don't insert into the stack, directly print it as the output. Remember, whenever you are getting open bracket, we have to insert into the stack. Whenever we are getting an operand, what should I do? Whenever I am getting an operand, I need to print it on the output. Or you can concatenate in a string. Finally, you can print the entire string as the output, or directly you can print based on your convenience. Okay, output A. I have printed A because A is an operand. Next, plus. What do we call as plus? We'll be calling the plus as operator. So I'll insert the operator inside my stack. So whenever we are getting brackets and operator, we have to insert inside the stack. Whenever we are getting operands, we have to put it on the output screen. So plus is an operator. So I'll be inserting inside the stack. I have inserted inside the stack. Okay, I have inserted. Next, what is the next element? B. B is an operand. Whenever I'm getting an operand, what should I do? I have to display it on the output screen. Okay. Okay, Sajid. So far, what we have discussed is very simple. Whenever we are getting brackets and operator, we have to insert into the stack. I'll start from the beginning. Okay, because many people are saying that I'm moving it too fast. So I'll repeat slowly now. Listen carefully. First element. So for this, we have to understand one concept. Whenever you are getting brackets and operator, you have to insert inside the stack. Whenever you are getting operand, you can print it on the output screen. The first element, which is nothing but open bracket. So whenever I'm getting open bracket, what should I do? I should insert that particular element inside my stack. Okay. The second element, again it is an open bracket. What should I do? I have to insert inside my stack. Done. Go for the next element, open bracket. So again I have to insert inside my stack. Great. Next, A. So A is called as an operand. Whenever I am getting an operand, I have to print it on the screen. So I'll print A. Directly I'll print A. Operands should not be kept inside the stack. Only brackets and the operator has to be put it on the stack. Next, plus. We know plus is an operator. If it is an operator, I should insert into my stack. Okay, great. Next one is B. What do we call B? B is an operand. Whenever it is an operand, I have to print it on the output screen. Now we might have a doubt. Sir, we have operands here. When do we print operators? We know postfix notation. When I go for postfix notation, operator will be at the last. Operand, then only we will be having operators. Okay. So go for next operator, which is closing bracket. So bracket close inside this. Whenever you are getting a closing bracket, for sure you will be having one operator here. You may have, you may not have. That is not sure. So whenever you are having a closing bracket, make sure the operator which is present inside this should be popped from the stack, which is deleted from the stack, and printed on the output screen. So when I get a closing bracket, if I have operator, take that operator and print it on the screen. Pop that, delete that operator. Plus, see, postfix notation. Infix notation is A plus B. Postfix notation is AB plus. But I have to write for the entire thing, right? Now let's continue the process again. Next one is star. What is the use of star? Which is an operator. If it is an operator, what should I do? I have to insert inside my stack. Insert. Done. Go for next one. Open bracket. If it is an open bracket, what should I do? I have to insert inside my stack. Okay, I have inserted. Next one. C. C is an operand. If it is an operand, what should I do? Print it on the output screen. Okay. Next, plus, which is an operator. If it is an operator, what should I do? I have to insert into my stack. I have inserted into my stack. Next one, D. What do we call D? D is an operand. If it is an operand, I have to print it on the output screen. Okay, I have printed on the output screen. Next one, closing bracket. So whenever closing bracket occurs, what should I do? I'll put it inside the stack. Whenever I'm getting a closing bracket, I'll pop the topmost operator. So closing bracket, right? So topmost operator is plus. I'll delete the operator called plus. I'll print it on the output screen. I have printed. Now go for the next element, closing bracket. So whenever I'm getting closing bracket, what should I do? I have to insert inside the stack, which means I have to delete the topmost operator. I have to delete the topmost operator. Star will be deleted. That will be printed on the screen. That will be printed on the screen. Okay. After that, what should I do? I have to go for the next element. What is my next element? My next element is, my next element is slash. Slash is called as operator. So I'll insert inside the stack. Next, open bracket, insert inside the stack. Next, F, which is an operand. If it is an operand, what should I do? Print it on the output screen. Next, plus, operator. If it is an operator, what should I do? Insert inside the stack. Next one is G, operand. If it is an operand, print it on the screen. Next, closing bracket. If it is a closing bracket, what should I do? Close this, pop the topmost element of the stack. Pop the topmost element of the stack. Plus has been popped. Next is again one more closing bracket. Okay, I'll close topmost element of the stack. Just operator has to be popped. Slash. That's all. I have converted the given infix notation to postfix notation. See, infix notation. Postfix notation, AB plus. So operators are kept at the last. Post. Is it clear, guys? So you have to remember two things inside this. If I am getting an operator and brackets, insert inside the stack. If you are getting an operand, print it on the screen. When should I pop the character? When should I pop the operator? When you have closing bracket, pop the topmost operator. Whenever you are getting an open bracket and operator, insert inside the stack. Whenever you are getting an operand, print it on the screen. Print it on the screen. Whenever you are getting a closing bracket, pop the topmost operator of the stack. This is how I have to convert the given infix notation to the postfix notation. Is it clear, guys? I'll give a minute of time for you to go through this. In case if you want to recall this, maybe after the session got over, you can watch this video again. It will be uploaded in our Facebook YouTube channel. Okay. Now let's move on to the next concept called evaluation of postfix expression. So now, how to evaluate? So I'll be getting an expression, right? If I'm getting an expression, I need to know what is my final answer. For example, 2 plus 3 divided by 5. So what will be my final answer? I need to evaluate an expression. So how to write a program for evaluating the expression evaluation? Okay. Precedence of operators. So we have to know which operator has to be given the more precedence. For example, I am getting two operators, plus and star. So which one should I give more precedence? Should I give for plus or star? So those things we'll see now. That is called precedence of operators. So dollar or cap, that is power symbol. We have to give the highest precedence. Next to that, we have to give multiplication and division. That should be given high precedence. Next, plus or minus, which has a low precedence. Next to this, equal to, will have the lower precedence. Finally, the brackets, lowest precedence. So this is the order we have to give a precedence for the operators. This is the order where we have to give the precedence for the operators. Clear? Now let's try to know how to evaluate a postfix notation. So when I say postfix notation, how can I do? This is what called as postfix notation. Now you might ask, sir, what if an infix notation has been given to me to evaluate? We know how to convert the infix notation to postfix notation. Yes or no? Just now we have seen. Convert the infix notation to postfix notation, then evaluate the postfix notation. Is that fine, guys? Now let us get to know how to evaluate the given postfix notation. Okay. The expression which they have given is 1, 2 star, 3, 4 plus, 5 minus plus. This is the expression which they have given for us to evaluate, and I have to give the final answer. Okay. Now let me tell you, this can be solved with the help of stack, because I told you expression evaluation is one of the best applications of stack. With the help of stack, we can evaluate this given expression. Okay, let us take a stack here. Okay, I have taken a stack. What is the first element? 1. So here we have to know the certain concept, right? When should I insert, when should I pop, when should I evaluate? So remember carefully, whenever you are getting an operand, insert inside the stack. Here we are evaluating. Remember guys, earlier we were transforming from one notation to another notation. Infix to postfix notation, we are transforming. Now I am going to evaluate the postfix notation. So when you are evaluating, whenever you are getting an operand, you have to insert into the stack. Okay, when I get operator, what should I do? I'll tell you. Okay, first point, when I get an operand, insert inside the stack. What is the first element? 1. Operand. 1 is an operand. If it is an operand, I should push inside the stack. Okay, I have inserted inside the stack. Fine. Next, 2. 2 is called as, again it is an operand. So what should I do? I have to insert inside the stack. Okay, I have inserted. Great. What is the next element? Star. What do we call a star? Which is called as an operator. Okay. What do we do when I have an operator? So remember, whenever you are getting an operand, you have to insert inside the stack. Whenever you are getting an operator, you have to delete from the stack. Okay. So how many elements should I delete? That is my next question, right? So whenever you are getting an operator, you have to remove the topmost 2 elements of the stack. Whenever I am getting an operator, pop top 2 operands. So 2 and 1. Okay. 2 and 1. I have popped the 2 more elements. After popping, what should I do in the sense? I should evaluate this expression. Evaluate. How can I evaluate? We have an operator here, right? And we have 2 operands here. So 1 into 2. People, you can ask, sir, remember I have 2 on the top. So the topmost element should be considered as my second operand, and below that will be considered as my first operand. Why? Because 1 is the first element we have inserted. 2 is the second element we have inserted. So 2 should be considered as my second operand and 1 should be considered as my first operand. Here people, most of them will confuse in this. Okay, listen carefully, because 1 you can say, sir, 1 into 2 and 2 into 1 both are same, right? Of course both are same. But when I go for division, 2 divided by 1, 1 divided by 2, I'll get different answer. So there is a chance of getting wrong answers. So make sure whenever you are popping an element from the stack, topmost element should be considered as my second element and the first element will be considered as my first thing. So here, see the image which I have, how I have taken 2. So 2 will be on the right and 1 will be on the left. Now I will be evaluating as 1 into 2. I will be evaluating as 1 into 2. So what is the answer I will be getting? 1 into 2, which is 2. 1 into 2, which will be called as 2. So if it is 2, what should I do? I have got my answer. I have evaluated. After evaluating, which is an element, what I have to insert that element inside the stack. I will repeat. Whenever you are getting an operator, pop the topmost 2 operands from the stack, and when you are popping, topmost element should be considered as my second operand and the next one more operand should be considered as my first operand. Okay. After that, evaluate the expression. After evaluating the expression, I have to insert that element inside the stack. Clear? Yes. Next, go for the next. That's all. After this, we have to move to the next element, which is 3. 3 is an operand. If it is an operand, what should I do? I have to insert inside my stack. Next element, 4. It is an operand. If it is an operand, what should I do? Insert into the stack. Done. Go for next element, plus. If it is a plus, what should I do? Operator. If I am getting an operator, I have to do one process, right? What is the process? Pop the topmost 2 elements from the stack and evaluate it. After evaluating, insert into my stack. So topmost element should be considered as my second element and the next element should be considered as my first element for the evaluation. So operator, pop topmost top 2 operands, 4 and 3. 2 elements will be popped from the stack. After popping these 2 elements, I have to evaluate the expression. So 3 plus 7 evaluated. So 3 plus 4. 3 plus 4, what is the answer I'll be getting? 7. Okay, I have got my answer. After getting the answer, I have to evaluate the expression. How to evaluate the expression? After evaluate the expression, what should I do? I have to insert inside the stack. So 7 will be inserted into the stack. Fine. Let's move to the next step. Next element is 5, which is an operand. If it is an operand, what should I do? Insert into the stack. It will be inserted into the stack. Next element is minus. So when I am getting minus, what should I do? I have to pop the topmost 2 elements of the stack. I have popped. Then evaluate. How should I evaluate? 7 minus 5. Okay. 7 minus 5, I'll get my answer is 2. After evaluating, I have to insert inside my stack again. So insert it back to the stack again. 2. Fine. What is my next element? Plus. Plus is an operator. When plus is called as an operator, what should I do? I have to pop the topmost 2 elements of the stack, evaluate it. After evaluating, what should I do? I have to insert inside the stack. Okay, insert inside the stack. Now go for the next element. Do I have any element? I don't have any element. That's all right. If I don't have any element to evaluate, just print the topmost element of the stack. What is the topmost element of the stack? 4. 4 is my answer. Print the topmost element of the stack. So 4. 4 is my answer. That's all. Is it clear, guys? Were you able to understand how to evaluate the postfix notation? We have seen how to convert infix to postfix notation, and now we have seen how to evaluate the postfix notation. I'll give a minute of time. Just recall this. If you have any doubts, you can ask me. So remember some steps. First step, operand, insert into the stack. Operator, pop the top 2 elements of the stack. Top element should be considered as my second element. Okay, then evaluate the expression. We'll be getting an answer. That answer has to be again inserted inside the stack. Repeat the process until you are reaching the final stage. When you are reaching a final stage, which means when I don't have any element here, print the topmost element of the stack. That is your answer. Print the topmost element of the stack. That is your answer. Is it clear, guys? Okay, so these are all the things which you have to remember when you go for the concept of stack data structure. So when you go for stack data structure, know how to write a implement stack using array and linked list, then learn expression evaluation. And one more important question we'll be calling as tower of Hanai problem. So remember tower of Hanai problem when you go for stack data structure. Okay. Now let me write a program for you and then I'll show implementation of stack. Okay. I'll give a minute, just go through that and read this question. If you have any doubt, you can ask me. Then I'll execute the program and I'll show you. Implementation of stack using array. Yeah, of course, Karuna Sagar. The concepts and the questions can be asked in the perspective of placements. Stack using array. So the question is, write a program to implement the stack using array. So I have to write a program to implement the stack data structure. You can assert we have inbuilt function, right? Then why do we write? Obviously we have inbuilt function, but we need to know how those inbuilt function works. For that you have to write the code on your own. If you know how that code works, then while using inbuilt function, that will be very useful for you. Okay. So here the questions they have given us, get the choice from the user. The choice may be 1, 2, 3, 4. So if the choice is 1, I have to insert element inside the stack. If the choice is 2, I have to delete an element from the stack. If the choice is 3, I have to display the element from the stack. If the choice is 4, I have to come out of it. Okay. So while you're performing, we have to check certain conditions. While performing the operations based on the given choice, for wrong choice input, for example, I told 4 choice only I have given. If I give me value as 10, we have to give a message saying that wrong selection, try again. We have to give a message saying that wrong selection, try again. Next, if the stack is empty when you are trying to delete, so we have to give a message saying that stack is empty, deletion is not possible. When the stack is full, you are trying to insert an element. We have to print a message saying that stack is full, insertion is not possible. What if the stack is empty? If the stack is empty, we have to give a message saying that stack is empty. So here they have clearly mentioned what we have to do. Now let's try to write the program for the concept of stack. Okay, so I'll write it in C++. So listen carefully. Okay, so I'll start from the beginning itself. And guys, whenever you're writing a program, make sure how am I writing the program and what flow and what order I'm writing the program. Okay, so I'll start with the first line once. Hash include IOStream. Okay, this is nothing but preprocessor directives. Then I'll go for one more preprocessor directives, cstdlib. Hash include cstdlib. Okay, I've taken two preprocessor directives. Now we have to give namespace, like using namespace std, because always whenever getting input we don't want to give std scope resolution operator, then we have to get the input value. So to avoid that, we'll be giving using namespace. Fine. We need to define the size of the stack. We need to define the size of the stack. And before this, I'll take a sample input. Okay, 1. I'll insert 10 inside the stack. Again, I have given 1. This is choice value. So I have to insert element inside the stack. So 20 has to be inserted into the stack. Again, I have given the choice value as 1. Insert the element inside the stack. 30 will be inserted. Now 30, 20, 10 will be present on the stack. 30 will be the topmost element. I have given the choice value as 2. When the choice value is 2, what should I do? I have to pop the element from the stack. So what is the topmost element? 30 is the topmost element that will be popped from the stack. That is, that will be deleted from the stack. Then 3. When I give 3, what should I do? I have to display the element of the stack. How can I display? 20 and 10 will be displayed because 20 is the topmost element, then 10 is the element. So 20 and 10 will be displayed. Then 4, which is nothing but exit, come out of it. That's all. This is what they have given in the sample input. Now let's try to write the program here. So whenever you are writing a program for stack, we have to define the size of the stack. Because when the stack is full, we cannot insert the element, right? So I am going to give preprocessor like macros. With the help of macros, I'm going to define define size. I'll give size as 10. Let's define the size of the stack as 10. That's all. So here, what are the functions we are going to give? Push, pop, and delete. I mean display. Push, pop, and display. The execution always starts with the main function. Okay, int main. Okay. So here what are we going to do? We have to get the value and the choice. Choice we have to give, right? So I'm going to declare a variable called choice. And one more variable I'm going to declare, which is value, because I have to insert inside the stack, right? For that I'll be declaring variables. And here I'm going to take array, because I'm going to implement the concept of stack by using array. I'm going to declare int stack. The array name I have given as stack size. So size I am giving. Okay. You can ask, sir, why do we not give it the integer value? Instead of integer value, we have defined size as 10. So here, whenever we are using the word size in our program, automatically it will be replaced as 10. So stack 10. The stack size is 10. And one more point I have told you, top value will be equal to -1. Initially, when the stack is empty, the value of top will be -1. When the top value is equal to -1, it states that stack is empty. Okay. Now I'll get an infinite loop. Why am I taking infinite loop? Because I may give n numbers of choices. Whenever I am giving a choice value as 4, I have to stop the process. I have to stop the process. Okay. So while 1, I have given while 1. Done. Now I have to get the choice value from the user, right? How can I get the choice value from the user? Cin choice. Okay, I have got the choice value. Then after the choice, I have to choose operation. Should I go for push, pop, display, or exit? I have to go, right? How can I write for that? By using a switch case. By using a switch case. Okay. So when you are writing, opening a bracket, automatically close it, so that in future will not have a worry about whether I have closed the brackets or not. Okay. Fine. When choice value equal to 1, that is case 1. When choice value equal to 1, what am I going to do? I am going to insert an element. To insert an element, I have to get the value from the user, right? So cin value. I'm getting the value from the user. After getting a value, I'm going to call a function called push. So which value has to be pushed? The value which I've got from the user. So value. I'm passing it as an argument. After completing this, I'll break this. If I'm not giving break in switch cases, it will execute all the cases. So I'm going to give break. Here, this is nothing but function call. This is nothing but function call for insertion. Function call for insertion. Okay, what if the choice value is equal to 2? What should I do? If the choice value equal to 2, I have to delete the element. If choice, that is case 2. If case is 2, what I am going to do? I have to delete. So pop. This is nothing but function call for deletion. I have called a function. I didn't define the function, just I have called the function. So after this I have to give break. Then I'll go for case 3. If case value is equal to 3, what should I do? I am going to display. Just I am calling a function called display. Function call for display elements. Okay, then I have to give break. Then case 4. If case is 4, what should I do? I have to exit. So I'm going to call a function called exit. So know the difference between break, return, exit. Break keyword is used to come out of a looping body and switch cases. Break keyword. Return keyword is used to come out of a function, just from a particular function. What about exit? It is used to terminate the entire program. It is used to terminate the entire program. Okay. So 4 choices only they have mentioned. 1, 2, 3, 4. 4 choices they have mentioned. I have written for all 4 choices. What if we give wrong choice value? So whenever I am giving wrong choice value, I have to display this message. Wrong selection, try again. Guys, remember carefully, here whatever they have given, the same thing only you have to type, or else your test case will not be passed. So if I give 3 exclamatory, I have to give same 3 exclamatory, which is default. So we know how default works, right? So I am going to give a default statement, which is that cout. If I give wrong choice, I have to give wrong selection. So S is not capital. So whatever they have given, the same thing only have to give. Wrong selection, 3 exclamatory and 1 space. Then I have to give it as try again, then 3 exclamatory. Close this. Then close with the semicolon. Semicolon says that we are in the end of the statement. And then I'll give break. And after this I have to give a break, right? Obviously when I give exit, automatically it will come out of it. So I don't want to take a break, but still. Okay, that's all. I have called all the functions. So based on the choice values, I have given inside the user. Now what I have to do? I have to define each and every function. Now I have to define each and every function. I'm going to define each and every function below. So let me, and after this is called main function, right? Yeah. So the return type of the main function is integer. So I have to give return 0. I'll give return 0. That's all. Now I have called 3 functions. So I have to define all the 3 functions, right? Let's define one by one. Okay. So let me declare the function before that. Okay, what is the first function? Push. Whether the function is going to return me anything? No. So I'll give return type as void. Void push. I have given one element as my argument. Okay, int. That is of type integer. Pop. It doesn't have any arguments, so it will not contain any arguments here. Then display. It will not have anything, so display. So I have declared 3 functions. This is called function declaration. This is called function declaration. This is called function call. Now let's go for function definition. So function definition is something, but outside the function we'll define. First we'll define. Is it clear, guys? I'll give a minute so that you can understand what I have written here so far. Okay, is it clear, guys? So I have defined, this is called function declaration, function call. Now we have to define 3 functions. So now push function has to be defined, pop function has to be defined, display function has to be defined. Exit is an inbuilt function, so we don't want to define this. It is an inbuilt function. Is it clear so far? Okay. Let me define the push function now. Okay. So the return type is void push. It contains an argument, right? The argument is of type integer, int value. That is what I have defined. So when I am going to insert an element inside a stack, what is the condition I have to check? I have to check whether the stack is full or not. If the stack is full, that is called as overflow condition, I told you, right? So what I am going to do, if top is equal to size minus 1, size I have given in capital letter, size minus 1. If top equal to size minus 1, what should I do? I have to give a message. If stack is full, I have to give this message. Cout stack is full, insertion is not possible. If the stack is not full, what should I do? I have to insert an element inside the stack, right? So how can I insert the element inside the stack? Top value has to be incremented. Top value has to be incremented. So what and all I told in the concept that I'm writing it as a program. Top value has to be incremented. Then stack of top, because we are going to implement the concept of stack by using array, right? So the array name I have given a stack. The index value should be top value, stack of 0. That is stack of 0. On the index value stack of 0, I'm going to insert value. So value which is given by the user, that has been passed as an argument, right? So that will be given. Stack of top value will be given as value. That's all. If the stack is full, I'll give a message saying that stack is full. I cannot insert an element inside the stack. If the stack is not full, I'll insert the element. I'll go for else case. I'll go for insertion of element. While inserting, what is the first thing I have to do? Top value has to be incremented. Then on that particular index value, on the index value 0, I'll keep the element. Okay, that's all I have defined the push function of stack. Now let's go for pop. How to write pop function? It's very simple. Void pop. Here it doesn't have any argument. What is the condition I have to check? I have to check whether the stack is empty or not. If the stack is empty, I have to display this message. So for that, if top equal to -1. If top is equal to -1, what should I do? I have to give a message saying that stack is empty. After 3 exclamatory, then deletion is not possible. That's all. If it is not satisfying this condition, what should I do? I have to go for else case. In the else case, what I am going to do? Just decrement the top value. Just decrement my top value. That's all. I have completed the function for pop as well. That is what I have explained to you, right? In the concept while explaining stack. Okay. Then what should I do? We have to define one more function called display. So void display. Here, while displaying, you have to check one condition. If the stack is empty, you should say stack is empty, because we are going to print the element. While printing, if you have empty stack, I cannot display any elements, so that I can say stack is empty. So I have to give one condition saying that if top is equal to -1, see out saying that stack is empty. That's all. If the stack is not empty, what should I do? I have to display the elements. So I'll go for else case. I have to display one by one. So to display the element one by one, I'll be taking a for loop. Okay, I have declared a variable I for I is equal to. The element has to be displayed from topmost order, right? From the top element will be displayed first. So we know which element is in the top with the index value called top. So I'll give I equal to top, I greater than or equal to 0. When I value becomes -1, it is empty. Stack is empty. And then I decremented, because we are coming from top order. I'll be decrementing the value from the stack. Now what I'm going to do? See out stack of I. And here the element are printed in new line. The element is printed in new line. So we have to give endl. Either you can give endl or you can give /n, whatever is comfortable for you. That's all. This is what the program is all about. Let's run the code now. Yeah, it passes all the test cases. All test cases have been passed. 2 visible I have given and 3 hidden test cases I have given. All the test cases have been passed. That's all. This is the program. I'll just explain the program. Preprocessor directive. I have defined the size of the stack. I have declared 3 functions which I am going to use. I have declared the stack. Top value I am given as -1. These variables are called as global variable. Okay. Now inside the main function, I have taken a switch infinite loop. Inside the infinite loop, I have taken a while switch case. Based on the choice value, I have to perform operation. If choice value is 1, insert. Choice 2, delete. Choice 3, display. Choice 4, exit. If I give any other choice, give a message saying that wrong selection, try again. Then I have defined all the functions. That is nothing but push function, pop function, and then display. All the function has been displayed. All the function has been defined clearly. Hope this is clear for you. Okay, that's all. This is what all about. Okay, and guys, Now if you want, okay, Anirudh, you are asking about to explain case 2. Case 2 is very simple. Okay, here what I have done, here in the question they have given, if I give a choice value as to, I have to pop. So in case 2 I am calling a function for deletion. I have given the function name as pop. So I will go for pop. I will be checking the top value. Based on the top value only I can say whether the stack is empty or full. Okay, I mean yeah, stack is full. So if top value equal to -1, we can say stack is empty. So if top value equal to -1, the stack is empty. So I'll display a message saying the stack is empty, deletion is not possible. If the top value is not equal to -1, I'll just go for top -1. So if the top value is 2, I'll come from 2 minus 1, 1. I'll come to the index value called 1. That element will not be considered. Topmost element will be considered, right? That is denoted by the variable called top. Yeah, great guys. And guys, if you are 2021 passed out and if you want to have more updates regarding your placements or anything, you can join our WhatsApp or Telegram group. I'll tell you how to join there. Sorry. It is faceprep.in. You can go to faceprep.in. After this, click explore, and here we have given faceprep edge. So click that faceprep edge, and after that, if you want to join our WhatsApp group or Telegram, based on that you can click the link. So here it is join WhatsApp group. After clicking join WhatsApp group, you can choose your preparation goal. If you are aiming for product company or IT service company, based on your choice you can give, or if you want to give for both, you can click IT product company as well as IT service company. And if you are 20-20%, just click here and then confirm. After confirming, it will redirect you to the page join chat. Here I have given WhatsApp web, right? I can say directly I can join the chat. In case if you are using your mobile phone, even in a mobile, because most of them will be using WhatsApp in your mobile phone, right? You can take your mobile browser, go to faceprep.in and go to explore. In that explore, give faceprep edge and then join the chat. You will be getting more updates regarding your placements and useful informations and daily bites and speed math. Everything will be shared to your WhatsApp group. Okay, and that's it guys. And if you have any questions, you can ask now. If you have any doubts or any questions to be asked, you can ask. I guess no questions. And if you have no questions, we can end the session guys. Thank you guys, thank you so much, and see you in the next session.